362 patches, 6 years, to delete one function, not a subsystem, not an entire API, one string copying function from 1974. And that question should be sitting with you through this entire video. Linux 7.2 has finally eliminated string builder from the kernel. If you run code on Linux, which is everything, everywhere, you've been affected by this function for decades. Here's the trap. Most developers read strnching as copy up to n bytes from source into dist safely. What it actually does, if the source is shorter than n, it zero pads the entire remaining buffer. Slow, wasteful, almost never what you want. And if the source is longer than n, no null terminator. Your string is now a memory corruption waiting to happen. The function named for safety is only safe if you already know it isn't and write extra code to compensate. In the kernel, you're calling string functions in hot paths, network packet processing, file system operations, device driver initialization. Every time strnch padded a 4-byte string into a 256-byte buffer, it burned CPU cycles on nothing, in the most performance-critical code in the world. The Linux Foundation linked this to real vulnerabilities. CVE 2024-39479. Attackers exploiting exactly those null termination overflows. Real CVEs, real exploit from one function. A function that has been in the C standard library since 1974. Dangerous the entire time. The replacement is strncpy, and this is where it gets almost poetic. Strncpy guarantees null termination. Always. Not usually, not if you remembered the right incantation, always. It does not zero pad the buffer, and it returns negative E2BIG if the source was truncated, so you know when it happened. No silent failures. According to a 2025 study by the Linux Performance Group, eliminating unnecessary padding reduced CPU overhead by up to 15% in some benchmarks. Safer and faster. Which raises the obvious question. If strncpy is better in every way, why didn't we do this decades ago? Because the kernel doesn't get to flip a switch. There were hundreds of call sites scattered across drivers, file systems, networking code, per CPU architecture implementations. Each one had to be hunted down, audited, and rewritten individually by contributors touching code they didn't write in subsystems they may barely know. This is the largest coordinated cleanup of a single API in Linux kernel history, and almost nobody outside kernel development has heard about it. The merge commit is real, and it's on kernel.org right now. This isn't theoretical. Linux 7.2 ships without Str6 as a kernel API. Now here's the take you won't get from the headline. This is being framed as a Linux success story, and it is. But it's also an indictment. Serializers wasn't some obscure edge case. It was in every textbook. It was what professors taught. It made you feel like you were doing string handling correctly when you weren't. A language design decision from the 1970s, making safe string copying implicitly unsafe, has cost the industry 50 years of CVEs, security audits, and remediation efforts. And we're still using that language to run the internet. But Rust's adoption in kernel modules has been rising as a direct consequence of exactly this kind of failure. The Rust in Linux push and the string elimination are the same story told from opposite ends. C's safety model requires constant human vigilance. Rust's safety model just won't compile the mistake. Blatant in Rust, it doesn't exist, because the type system ate it. Go, Swift, Kotlin, languages designed after we learned these lessons, never needed 362 patches. They needed a correct string type from day one. The kernel developers deserve enormous credit for finishing this, but the next time someone asks why the industry is moving to memory-safe languages, point at this commit history. This is the cost of not starting there. If you write kernel code, this is urgent. Check your existing strncpy calls. They will not survive the Linux 7.2 merge window. Run grep recursively across your drivers, net, and fs directories and start triaging now, not after the merge window closes. If you write user space C, embedded systems, firmware, strncpy still exists in glibc and isn't going anywhere. But the kernel just ran a 6-year experiment proving the cost of leaving it alone. Integrate static analysis. Use -w string op truncation in GCC. Use clang tidy's bug-prone, not null terminated result check. These tools exist. Run them. Update your CI/CD pipelines to block deprecated functions before they block you. This is preventable from day one of a project. And if you're the developer on your team who just said, wait, strict is dangerous, you are not alone.